Hello and welcome to another Solana tutorial. Today we're gonna do something fun. Something that has no purpose. We're just gonna do it because we can. Today we're gonna create ourselves a vanity signature. Or vanity signatures for our transactions. Woohoo! This is so pointless that I'm really excited to do it. I mean, the thing itself is there's no reason, no practical reason why you would want a vanity signature. But it's kind of art, right? It might not serve a purpose except for being pretty and it's a form of expression. And really, I'm doing this such that we learn stuff on the way. We're taking this thing that we want to do, and by the process of doing it, we learn something, even if the outcome we can't really use for anything. Those kind of projects I enjoy because they're so pointless that it kind of is fun to do them or something. Because if I work to get something done that is productively used, I mean, that feels a lot like work, whereas this feels a lot like play. So let's go and have fun. Yes, let's have some fun with vanity signatures. Okay, so step one, what I would recommend for you, if you have experience with Solana and you're not a complete newbie here, is that you think about it yourself. How would you do it? Your goal is to have a vanity signature. If you don't know what a vanity signature is, maybe I should define that. It's a signature, a transaction signature, where the first few letters of the signature basically spell something. So we have the base 58 encoding that we usually use for signatures on Solana, and those letters say something cool. That's a vanity signature. When you grind a key pair to find a vanity address, it's the same. Then the public key of that address will have certain letters in the beginning or the end or whatever you want, right? And for a vanity signature, it's the same with the signature. And as far as I know, nobody ever did that. Why would they? It's pointless. And also, I don't know everybody who ever does everything. So maybe somebody did that. But I want to do it myself today. And I want you to first think about it, how you would do it. And then you compare your solution with how I would do it. And I'm going to talk you through the steps I take to come up with my solution. And then we compare, or well, you will compare because I don't know your solution. And maybe you learn something. You learn, oh, that's what I could have improved. Or you tell me, hey, my solution is way better. Try doing it like this. And then you leave me comments and then I'll be like, wow, yeah, people are smart. Because people are smart. And we're probably not going to have the best solution. There might not be such a thing as the best solution because again, we're in technology and everything is a trade-off. But yeah, we will play around with vanity signatures today. And I hope it's going to be fun and we learn something on the way. So if you're up for that, come and join me on this episode of Solandy's Having Fun with Solana. Let's get started. I'm so excited about this. In case you can't tell by my emotions. Yeah, I'm really excited about this one. I was like, what video could I possibly make today? Oh, that all seems like work and exhausting. And then I came up with this and I was like, yeah, that's the one. Then we gotta do that. It's been on my list for a long time, but somebody at Island DAO told me I should make that video. Who was that? Was that B-Man? I don't know. Yeah, somebody was like, vanity signatures. I'm like, yeah, it's on my list. And today we're actually gonna do it. Let's do it. Okay. Are we ready? Are you ready for this? Did you think about your solution already? Did you try it yourself? Do it yourself. It's a great challenge. I love challenges. Okay, let's get started. I'm so excited. Let's go. Hello, Visual Studio. So we're gonna do this in Rust because Rust is more efficient than TypeScript, and those are really my choices. I want the Solana libraries. And again, I might not be doing this the most efficient way. You can improve on that if you want to. First of all, we're just gonna learn and figure out how it can be done, and then we might optimize. But anyway, point is, we're gonna do this in Rust now. So let's cargo init, and then we have a main Rust file. And then I'm going to copy together a simple transaction sending script. Since I've done that before, I'm just going to, copy from other projects. That's a short little script that will do a transfer of 0.001 sol. And yeah, just send that transaction. Nothing special here. And we will need the Solana program crate. Hold on, we're not going to write a program. We're writing a script. Forget that. We will do the Solana SDK and the Solana client. We're not writing an on-chain program, we're writing a client-side script. And that builds, wonderful. Now I need to change the key pairs, hold on. Let's do a Solana grind. And here we're creating a Vanity key pair. That starts with, I don't know, let's do a transfer from me to you. From me TG, to you, UK. Okay, I'm gonna make a folder for this. Don't like my keys living out here. Also don't like my keys publicly visible. Gotcha, move. So from keys, me, from me to you. Now Solana airdrop to Sol to me. And then this should already work. Cargo run. Yeah, unused imports, I don't care. We're sending from me and we get this transaction signature that starts with 2 UG. Haha. Or maybe that's also a good thing that we can discuss in a second. We go to the Explorer and we see we've sent from me to you 0.001 Sol. Just a simple transfer. So we're not going to do anything special in our transaction. Of course you can do something more fancy here. You can build whatever transaction you want and then create that Vanity signature. But I'm just gonna do a simple transfer. You know, that's easily replaceable. But before we're gonna create a Vanity signature, let's discuss what we expect the signatures to look like. Because we kind of already discussed that in another video on the base 58 encoding, which is one of my favorite videos to mention because we constantly need that knowledge. And when I did that, I also had a look at what the signatures usually start with. However, that part I didn't cut into the video because it's basically the same process and you wouldn't have learned much more. But today I find it somewhat relevant that we talk about this. What do signatures usually start with? And you might have an intuitive sense already. Like this looks a lot like a Solana signature. If the signature would start with something like this, MDM, then you would be like, oh, that's an odd signature. Why? I mean, we can just have a look at random signatures. How would I do that? Let's just go to this block here and then check signatures. So we have 5x552. The X is a bit odd, isn't it? 22H33. So usually the signature starts with a number, no? And if I send another one from me to you, what's it gonna start with? N. Oh, well, that's a bit of an odd signature. Next one starts with 3 again. That's something that I would expect. Next one starts with 2 again. That's very common. Next one starts with 2 again. As I said, very common. Next one starts with 3 again. There's a pattern. Next one starts with T. That's a bit uncommon. Next one starts with 2 again. Oh, I haven't said that before. 5. And one thing that we already noticed here, I don't need to always send that transaction because I will slowly be running out of Sol here if I send you all my money. I could just, instead of actually sending, just print me my signature. How would I do that? I say transaction get signature. And what that does internally is basically from the transaction signatures get number 0, because that's the signature of the fee payer, and the signature of the fee payer is always the transaction ID or the transaction signature that represents the transaction, in case you didn't know. We can also have a look at that here. Yeah, there we see it. It gets from the transaction signatures at 0. That's the literal implementation of it. Cool. Yeah, so we print the signature. The signature, if we print it, will already print it in base 64. Can also do this just so I can have a look at this definition of the signature. Oh, there's a new unique from random. Oh, that's helpful. We're gonna look at that. There. When we debug, so that's when we print it, or display rather, but it's the same. When we display it, then we write it as base 58 encoded into string. That part of the code actually makes it this base 58 string. Otherwise, the signature is really just the bytes. And if we were to optimize, then we could use a more efficient implementation for this, but that's future work, I guess. Anyway, what did we see? We have a new unique unique. So yes, I could sign this transaction. There we go. Then we get 5. But if I'm just interested in signatures, what I could also do is be like, well, print me such a signature. Wait. How does Rust work? Oh, sorry, we're in Rust. That's how you do it. Oh, I'm using too many languages. I'm just getting confused. So here we can do the new unique, and then we get a random signature, and we'll print that. Again, we're in Rust. That's how you write this. And we get the signature from the transaction we signed and a random signature, just random bytes that we interpret as a signature. And it starts with 3 and then 4, proving that most signatures start with numbers. And I can do that several times. I'll put it in a loop, print myself 100 random signatures. And that's gonna run relatively fast, I tell you, because we're just creating random bytes and then creating signatures. Boom, basically instant. And we have 100 signatures. And if you just look at the first letter, it's usually a number. Sometimes it is not. And when it's not, then it's 1 character shorter. We've seen this before. That's the same as we have with the vanity addresses. And with vanity addresses for a pub key, 32 bytes, we said it's usually between 2 and H that are the common letters. Because the maximum, when we have all 1s in a 32 byte string, all 255s in the bytes, all 1s in the bits, then the address was something like J something. And let's find out the same thing for a signature. What is the largest signature there can be? Let's do largest sig, do a signature from, and you need a value from. I'm just gonna copy this code. And you have signature bytes, okay, then 255. Let's see, if all bytes of the signature are 255, what's the actual signature gonna be? Let's run it. I'm expecting something with 6, is my prediction. Because the letters, yep, there we go, 6, 7. So this is the largest possible signature, this one. There will never be a 6, 8 with that length, because we only have 64 bytes. And if we base 58 encode that, then the largest value is this. And that is why most signatures start with 2, 3, 4, 5, or 6. 6 actually not that common because 6 only up to 7. All the others with all the letters. So really, Solana signatures usually start with 2 to 5. Most of them. They only start with something else if they're 1 letter shorter, like this one. Then they're 1 shorter and then they can start with everything. Well, everything inside base 58. So that's something that we need to consider when doing a vanity signature. We already need to basically have the first letter be nothing in our signature. So it's basically already 1 letter, unless we start with 2, 3, 4, or 5. So if our vanity signature starts with 2, we basically get 1 character free. If that doesn't make sense, don't worry. I'll stop talking about this now. Basically, I just wanted to make the point that this is why most Solana signatures start with numbers, because of the base 58 encoding of the signature. And that's just the largest value. So basically what I'm saying is we're as likely to have a signature starting with 2 as with any other letter than 2 to 6. 1 is gonna be even more difficult because 1 means the entire first byte is 0. So it's unlikely that you find a signature starting with 1. Okay, so enough about the likelihood of text here. Let's actually get to the part for creating vanity signatures. I mean, it's easy that way if we do random signatures to find some that we like. And I mean, why not? Let's actually implement that part. My matching would be something like, if my random signature to string, and again, that does the base 58 encoding, starts with, let's say, Andy, then I print my signature. I will probably not find one within 100, but let's do 10K and let's see if I find myself a vanity signature. That should still all be relatively efficient. That's just random, and this is the base 58 that takes the longest. We did not find one that starts with Andy in 10K, but it ran relatively quickly. Let's do 100K, just so we get a feeling as well how many signatures we will need to produce to find a string with 4 letters. And 4 is probably already too much. 4 is a lot. Like here, even if we use just random, this is grinding quite a bit and still didn't find anything. I'll do 1,000,000, and if we still don't find anything here, then we already know that we can basically give up on finding 4 letters. And this is gonna grind a bit, like this is gonna run for a bit here now. You gonna find one or you're not gonna find one? Probably not. Nope, not even in 1,000,000. So let's just print all the ones with A. Those should be hopefully a lot. There you go. There are signatures that start with A, but notice how they're all shorter. They're all the same length. So yeah, that will do. AN will still be relatively quick to find some, but it already takes quite a while, considering that this is still like the efficient part. Random bytes and then base 58 encoding, and starts with is a relatively cheap operation as well. A and D, now we will need to wait several seconds, I guess, but this we should still find. So my expectation is we will find vanity addresses of 3 letters if we wait a bunch, because that's comparable to a 4-letter vanity address that starts with one of the letters that we get for free, but with signatures we don't get any letter for free, just numbers 2 to 6. Yeah, and with 3 letters it's already taken a while. Probably in that setup we will only get 2 characters with, you know, those libraries. Unless we use anything more efficient, we will probably just find... Oh wow, and it didn't even find any in the 1,000,000. Maybe that combination is bad. Let's do this. Maybe that combination is better, or we're just more lucky now. But yeah, so 3 letters we managed, at least while we're not actually creating signatures. Okay, that's a good first test. And E even. And this one again is always one shorter and another A and D. Nice. We could also be like contains. Maybe we manage somewhere in there to get 4 letters if the position doesn't matter anymore. There you go. An Andy. And this could also be a vanity signature, right? If you have a hidden message candy somewhere inside the signature, you know, you define what a vanity signature is for you. Contains is a bit less efficient because it steps through, but still a cheap operation in comparison to signing. Another Andy in here. I like it. And another Andy in here. If we just want to encode a word somewhere in the signature, then we will find signatures with 4-letter strings. That's possible. Okay, good. But for now, we just did, you know, random signatures that are not actually transaction signatures because, well, there's no transaction behind them. So let's actually get to the point where we create a valid signature, such like this one, that comes from an actual transaction with an actual recent block hash that does an actual instruction. So what do we need in order to be able to do something like this? Create several signatures. What do we need to do? Well, we need to change something inside our transaction, because as soon as something changes in the transaction, the signature will change. Now, the first thing that we can try and change is the recent block hash, but that might not be the smartest idea because, well, we want to first of all use a valid recent block hash such that we can then actually send the transaction as well. And there are only like 200 block hashes that are valid. And we could query new ones every 400 milliseconds, but getting one new signature every 400 milliseconds will not be enough for us to actually find a nice signature. So that's probably not the best idea. We can use a different sender every time, you know, a new key pair, just a different key pair to send from, to sign with. Yes, we could do that, but then we would need to, first of all, create so many key pairs in the first place because we would need to sign for them and then fund the correct one before we send the transaction. That's also a bit complicated. So of course, the obvious thing to do here is to change the message. Message being, you know, what the transaction should do. And inside the message, there is the instructions. So one way to go about this could be to just play with this instruction. So for this instruction to change, we could transfer different amounts of lamperts. So we can, add a lampert at a time. Every time adding one lampert, we create a different signature. I mean, that sounds like a good idea. Let's do that. We start at 0.001 sol, and then we just increase it. So let's do the loop here and use this signature. I want it to start with just an A. Let's start with just capital A. We don't need that. And then we might as well send it directly. We'll do +I, so we always change the amount. Let's see. I mean, that would be one way to do it, right? Let's try. Let's run this. We change the instruction and hope to find ourselves a signature that starts with A, and if we do, then we send it. Boom! Found one. Let's send it. That was easy. Oh, we found another one. So that's actually not too difficult, because one letter you find relatively quickly after 834 tries, or the first one actually after 339 tries. Maybe I should return here after we're done. And let's go with 2 letters. Let's go with XO. Let's see if we find a signature with 2 letters and how long that takes. It does take a bit longer. There we go, but it does work. We get a signature starting with XO, and that is our first real Vanity signature. Yes. Look, Vanity signature XO. But it took 46,000 tries to find it. And maybe here you already see the problem. If we're doing it like this, at some point this is gonna get expensive for me because I need to send you more lamperts. So obviously, maybe I do not want to change the actual amount of this transfer instruction. There must be something else that I can do and not tamper with the actual, functionality of my transaction. What I could do to, just change the instructions is add another instruction. I could also do the same with adding a compute budget instruction to set the priority and just increasing the priority, but that has exactly the same effect. At some point it's gonna get expensive. So I would leave functionality the same and maybe add a memo instruction. That could work, right? I add a memo instruction, and that would be a valid way how to do it. Just a memo instruction and a random string that you log, and the random string that you log changes the transaction signature because it changes the message hash. But even the memo program, or even if you call the no-op program with some random data, that takes CU. So the question is now, is there a way to randomize my transaction signature without needing more compute? With staying at my 150 compute that I need for this one simple transfer. Think about it. If you would have just added an instruction, we can do that. It's not that difficult. We can do that. Let's do, I guess we will need to cargo add memo, SPL memo. And then as the memo text, I can also just use I directly as bytes. Wait, but then the memo might fail because the memo instruction actually checks if it's a valid ASCII character. So maybe I shouldn't use that as bytes then. Then I do this to string and that as bytes. Then I log the actual number. And then I put that memo instruction in here. And that would now be a similar thing where we can find our XO by running this. There we go, we found one. XOR. There we go. Now we don't have the problem that we're sending too much. But we have a separate instruction to the memo program. 23K we see it took us to find. And because we do memo stuff, we now need a bunch more compute. So now our total transaction has more than 3K compute usage. Which, in most cases we can afford, but it's not optimal for me. Maybe I really want that, or maybe my transaction was already so much at the limit of its size and I don't want to add another instruction. What else can I do if I don't want to add an additional instruction to give me that random data to get different signatures? What if I don't want to do that? Well, I can tamper with the instruction that I already have. And maybe not the amount, because that changes the functionality again. But what I can do is add an account. So what I do is I get a random public key from pub key. Actually, I'm gonna do new unique because that's more efficient than getting an actual random one. So let's call it nonce pub key, because this stuff here just uses a static U64, initializes it at 1, and then always gives me the next one. Yeah, so that's more efficient than actual random. And so I just need to put that somehow into my instruction, and I'm just going to manually do it by instruction accounts. I'll push this account meta with the following pub key, my nonce pub key. It doesn't need to be a signer, and it also doesn't need to be writable. And then I need to make this mutable such that I'm allowed to do this. And then I basically just add another account to this transfer instruction. And this will also do the trick. It should do the trick. Let's have a look. There we go. XOG. Transaction was still sent. We were still fast enough to get the block hash and then this signature. So we're back to 150 compute units as I wanted it. And look at this. We have an additional random pub key here because we added it to the transfer instruction. We only see that if we click on raw here. We have a third account that we give to the system program transfer. And the system program transfer ignores it because it already knows the destination and the source. That's those two accounts. This one, it will just ignore. We just use it for us to get this entropy to get our custom signature. But is this the best solution yet? It's the best solution so far, yes. But can we do better? What could be the problem with this? I mean, with the system program, it doesn't really make much difference because the system program is nice and just ignores that and doesn't fail if we provide an additional account. Some programs will check that there's exactly the right number of accounts, and then they will fail on you if you add another one. And secondly, the program will need to deserialize that or at least skip over the deserialization, and the runtime will still need to read the state and build that byte array for this instruction. We don't really care about that because all we care about is the compute usage, which for the system program is one static value, so we don't feel it. But if it was any other program, a user space program, then we would see at least a little bit of difference in the compute units used, simply because the deserialization of that account will need some compute. So instead of putting that account here into that instruction, how about we just put it here into that transaction on a transaction level? We keep it here, but without ever using it. Can we do that? Of course we can. Why not? Why would we not be able to do that? We can sign any kind of transaction, right? So instead of changing this instruction and adding that account in here, why not adding it to the transaction? So once we have the transaction, I'm gonna make that mutable. And then I say transaction message account keys. And here I just push my nonce pub key. Cause why not? Now, however, I still have the wrong signature. So what I will need to do is I need to say transaction sign with my sender again. But since this new also creates me a fully signed transaction already, this one will perform a sign. So I would, double sign, and that's inefficient. So I'm gonna put that out here. And in here, just, add the nonce account and then sign the same transaction again. That should work. Run it. And it does take some time. And that's just for 2 letters. We just have a minute, otherwise the block hash expires as well. I might still be doing something wrong now though. I wonder why this is slower now. Maybe because I have a mutable transaction. Just want to see how fast this one is. There you go. 6, 7, 8, 6,000. And after 6,000 we have a transaction signature that works. So that seems super fast, right? However, there we go. But after 40,000 found one. Back to when we re-sign. Let's see how quick that is. Because this seems to be much slower. Oh yes, a lot slower. Why are we so much slower now? That's weird. Okay, Hold on. I'll just message account keys. Why would I change the transaction if I can change the message? I'm just gonna push the nonce pub key in here. Then I don't need to double sign this. I just make the message mutable. That should get me back to regular speed again. Yeah, we're back to regular speed and should find it. There we go, XOXO. And we stay at the 150. We have this random pub key in there, and we don't have it in the system program anymore. The system program just takes those two, and we basically just added an account here that does nothing. That doesn't even exist. It's not writable, it's not a signer. So the runtime really doesn't need to do anything with it. It never really needs to read it because none of the instruction uses it. So in my opinion, this is the cleanest way how to add some entropy to my transaction without changing the functionality. And we have a full pub key of entropy, that's 32 bytes, that should be enough to find us a signature that we want. And we can, just use random pub keys here. We wouldn't need to go with unique, we can use any random, but I think this unique is still a bit faster than if I were to create a random one. Yeah, and that's my implementation now. That's how I would create a vanity signature. But sadly, I can only do 2 letters because I'm not particularly efficient. As soon as I do more, let's say I wanted to say thanks. Thank you for the service. Here's the transaction. Let's see. If we find 3 letters before our block hash expires, how many signatures would I expect that we need to go through to find 3 letters? A bunch. And this is not fast enough. No, it is. Look, 3 letters. We can do 3 letters. Thank you, JG. There you go. There you have it. Thanks. Custom vanity signature for an actual transaction that we actually sent. From me to you. Thanks. I like it. This is cool. We managed a vanity signature. Were we just lucky or can we do that again? Thanks. It is working. So at about 50k. Yep, 50k. We need to find 3 letters. Tell me we were lucky twice. Apparently we were just super lucky twice in a row. Yeah, that's more what I would have expected. That makes sense. Okay, so we need to speed this up. We need more signatures per second. How can we do that? We might be able to speed it up a little bit by not running this thing in freaking debug, but by running it in release. So we tell the compiler, hey, don't do any checks that are not necessary. Just be as efficient as you can. So it's now rebuilding everything efficiently. And then hopefully it's going to be a bit faster as well. I mean, the problem is the signing. When we create a new transaction, we sign, and that is the expensive operation. That's why we can't get so many signatures, because we actually need to perform the, signing algorithm. That's the bottleneck here. Oh, look at this. This is way more efficient. Nice. That makes a big difference. A big difference. Wow. Wow. Good. So if you want to be efficient, compile in release. There we go. Thanks, T. Works. Just took 500,000 signatures. So maybe we will also find AND like this. I should make it a parameter such that I don't need to always rebuild the script. But then also I'm lazy. AND are almost my name. And it was even within the minutes such that the transaction actually exists. Vanity signatures. Now the next step would be to periodically also update the block hash such that this doesn't expire and we can, grind for longer. Every 1 million signatures, for instance. Yep, but no. This one, apparently it doesn't like it. For some weird reason, AND seems to be more difficult to find. Because if I wanted to find something like 422, that should be super simple. That it should find, within 100k. There, within 2000. Because the 4 we get for free. There is no 0. That's why I couldn't do 420. But I can have a lowercase o. There we go. Can do that. That's simple. Maybe even 4 letters like this should be possible. This transfer here is for you, after all. It's 4 letters, so it's like finding 3 letters, just you. But possible. There you go. It's for you. For you was co. Boom. For you. From me to you. Nice signature, eh? So 4 letters is definitely possible. You just need to start with 2 to 6. Well, 2 to 5, really. And this is approximately the same difficulty as just you. Here we have like 500k signatures that we needed. I'm expecting roughly the same. There you go. Roughly 5k. You and me. Nice. Vanity signatures. Vanity signature with 4 letters. Cheating a little bit. Do we want to make this more efficient? Because, I mean, my next steps would be to add some threading. I don't know if there's a more efficient way for signing than this sign function. I mean, we could optimize that, get rid of a few checks, but I don't think that would make it. But yeah, making this more efficient, or, you know, throwing more compute at it with more threads, that would just be an exercise. Let's let ChatGPT do that. Well, ChatGPT, I trust you. You got this. Oh man, we're even doing mutex on the shared. We're even sharing a counter. This could make this very inefficient again. But whatever, let's try it with 4 threads. That's not much faster than with 1 thread. How was it with 1 thread? Oh, I need to run for release, of course. I need to run in release. There we go. That's with 1 thread. And now with 4, better. Much better. Okay, let's add a 0 here and add a 0 here. I think that mutex is fine because the problematic thing is still the signing and not the locking of that mutex, I guess. While the others are signing, we can lock. That's fine. Okay, let's see if we find A and D as a signature with 4 threads. Let's go. Still recording as well. I still have enough power to record video. Could use more threads. There we go. We found one. Yay. AND7. And it's actually sent as well. Vanity signatures. 3 letters. Okay, so 3 letters are possible. I don't think we will manage 4. I'll be honest with you. 4 is gonna be difficult. Maybe if I ignore case. What's the most efficient way to do this? Before I do 2 lowercase, I probably want to access it like this. So this should now hopefully get me case insensitivity. And I already had one here, A and D right away. And here as well. Oh yeah, there we get a lot more signatures now. Wow. All the 4 threads found one with A and D if we ignore case. Okay, cool. So ignoring case helps a lot. Let's try finding A and D Y. 4 threads. Let's go. There we go. We found one. Found another one. Cool. We've got vanity signatures with 4 letters. Case insensitive though. Andy signature. You think we can do 5? No, 5 will be almost impossible, I guess. But hey, if you don't try, because another letter, this would be crazy. However, we could speed this up a bit, add more threads. Yeah, 16 threads. 16 threads is about what my computer can handle while recording. But hey, we found something! Oh no, I stopped it too much. Too early. It didn't send the transaction. But we found a transaction that would have, after only 5 million signatures. Case insensitive, we found NDS. Let's do it again. I won't stop it prematurely, sorry. Oh yeah, it's running hot now. Poor little computer. Nope, even after 10 million, I didn't find one again. I mean, yes, we were lucky to find 5 characters. 13 million. 21 million. 31 million. 41 million. I think 5 characters are just too much. 4 letters. How fast is that again? But yeah. You know what? Then let's do thanks and say contains. Let's see if we find a signature that contains thanks. That's 6 letters. Oh yeah, there was one. That was fast. Oh, there. Thanks. Yeah, it's very difficult to spot, but this transaction signature actually says thanks. Check this. Vanity signature starts with 6, as you would expect. And then it says some more thanks. Come on, we can do better. And also this gets confirmed. Thanks. So those are also vanity signatures with 6 letters. But you know, it's just in there. It doesn't start with it. So that's kind of boring. I can also say ends with. Whoa, that's fast. So 3 letters, fast. Especially if we ignore case. So there we can easily do 4 again. Thanks you. Thanks you for watching. Thanks you. But actually I prefer the starts with. So yeah, this is actually very similar, who would have expected, to grinding key pairs. 4 letters, ignoring case is possible, relatively easy, possible. With case sensitivity, I can easily do 3 letters, potentially 4. And yep, there we go. Thanks, thanks, thanks. So 3 is possible, 4 if we ignore case, and 5 potentially if we ignore case. And 4 potentially if we don't ignore case. That's with my implementation at least. And that is very similar to what we are used from Solana, keychain, grind. If I do 4 letters, although actually this one is a bit more efficient. Here I can do actual 4 letters a good amount of time because it starts with A. That's the cheating here. If I wanted to have one with lowercase a, then we are at the same. We will need to wait a long time. So 4 letters with a regular computer will take quite some time. And that's the same with those vanity signatures. Just that with the vanity signatures, we don't get a free letter if we use a capital A to H. Yep, but I guess that's good enough for me. Bye. There you go. Bye-bye. Bye-bye TN. Bye PH. Bye. Bye 4A. Thanks for sticking around and watching me send sol from me to you, my other me. It is fun. It is fun. We have vanity transaction signatures. Now, if you have a more efficient implementation, if you manage 4 or more characters, let me know how you do it. And otherwise, I hope that you learned something. Let me get bigger. I mean, maybe you want to use this next time you send someone some sol or do something else. You know, when you send them the transaction signature, you know, the confirmation. Wouldn't it be fun if the signature would start with something or end with something fun? And now you know how to do that. As I said, it's pretty pointless, but it's art. We're doing art here. It looks good. And it's just to prove that it's possible and to maybe understand Solana a bit better. I never claimed that this would be a productive endeavor. I just said we're gonna have some fun. And I had a little bit of fun. And then it's a lot of waiting for it to grind signatures, and that gets boring quite fast. So yeah, we gotta end it here as well. So watch some other videos. Subscribe if you haven't already. I do sometimes post productive stuff. And yeah, if you enjoy unproductive, give me a like and I'll see you in the next video. I have ideas for more interesting topics in the future. Until then, bye bye.